Suppose you could redefine education. You could do whatever you want. Where would you start? Let's say we start with the classroom. So I'm a university student, and when I go to class, I find it difficult to concentrate and listen to the professor while taking notes at the same time. The other thing is I have unusual sleeping patterns. And a lot of times I wish I could just pause what the professor was saying, take a nap, and then when I wake up, just hit resume, and the professor would just carry on. Well, there's this cool guy named Sal, and he's created he created something called Khan Academy. What Khan Academy does is he made a collection of YouTube videos. He started when he was, in 2004, he started tutoring his cousins, and his cousins actually preferred him on YouTube, where they could play, pause, and rewind their cousin as much as they wanted over actually seeing Sal in person. So Sal has over 3,300 videos on everything from math, science, art history, and we have even more faculty now. We have Vi Har, we have Beth and Steven, we have people making videos on cryptography, art history, mathematical doodles. So as Sal was making these videos, an interesting thing started happening. Teachers started taking these videos and assigning these videos as homework for students. And then, when the students came to class, they would be doing the homework during class. So what this enabled was it enabled a more personalized instruction for the teacher. So for example, suppose that there's a class working on exercises on Khan Academy. Here we have various displays of the data, real-time displays of what students are working on right now in class. Here's an example, and we can see blue means proficient, and red means that a student is struggling on an exercise. So in this case, we have Maureen. She looks like she's struggling on multiplying decimals. We can take a look, drill down a little deeper, and see what Maureen's doing. It seems like she's really struggling on multiplying decimals. It'd be really good if we could just see, maybe there's a common misconception she's having that's causing her all this trouble. So maybe we could look at the last problem she was doing, and we can see that, it looks like she started off thinking about it for 30 seconds, and then she entered an incorrect answer, waited for around 6 seconds, and then entered another incorrect answer. And afterwards, she took a few hints. So armed with this data, the teacher could try to figure out what it is that the student doesn't understand, come up to Maureen and talk with her, and explain to her what it is she doesn't understand. So you might also be wondering, 2 screens back, how we were assessing whether a student is proficient in an exercise or struggling. So I'll tell you my story here. I was an intern in 2011. I joined Khan Academy in August of 2011. And one of the Bens, so interesting fact, at Khan Academy, we have 4 developers who are all named Ben. And if you're going to apply to a job at Khan Academy, and if you happen to change your name to Ben before applying, you might have a higher chance of being noticed. So one of the Bens came up to me and a designer and said, "Okay, here's a problem that we're having." He wanted us to figure out a solution, ship something in a week. So the designer and I, the first thing that we came up with was basically this spaceship. All it worked was this. So the problem was that with the way we were assessing proficiency, we were saying that if a student gets 10 problems correct in a row, then we say that they've mastered the exercise enough that they can move on. The problem was that the students, when they get to their 9th problem, they would become very anxious. They would become paralyzed with fear that if they get a problem wrong, they would have to restart their streak back to 0. So what we wanted to do was we wanted to make it easier for the students to experiment. And our first solution was we had this spaceship, and all it did was that when you got correct answers, it would accelerate, it would go faster. When you got incorrect answers, there would be these gnomes that drop on it, and it would slow it down. So we were almost about to ship this ship when we thought, well, if we do this, we're going to be changing what proficiency means. It might be easier for students to get proficiency. Maybe we should do something else. So we took a conservative option, and we just decided to replace our streak bar with just fill the bar. So we took away the concept of the streak, and we just said, all you had to do is you have this empty bar, and you just got to make it full. And then if you get something wrong, it will go back a little bit, but it gives us the opportunity to change how the backend model works without disrupting the user interface. So I thought about this a little bit, and when we shipped this, I thought, what could we change the model to be? We have a lot of historical usage data on users, so I thought maybe we could build a model directly on that data. So what I ended up doing was I created a model using machine learning, which would basically compare your current performance history with the usage history of all the students before you, and it would say, okay, we think, to the best of our ability, that there's a 95% chance you're going to get the next problem correct. And if that's the case, then we can say you've mastered this exercise. You can move on. So I hacked this up on the weekend. I demoed it on during the week, and I was able to bring along Jace, one of our full-time devs who knew a little bit more about machine learning. And together we built this. We built the first learning model for Khan Academy, which we shipped. So the first thing we did with this learning model was that we used it to directly power proficiencies. We found that with this new model, we were able to obtain, we awarded 20% more proficiencies than the original strict model. The interesting thing was that if you were proficient in the old model and if you were proficient in the new model, they mean the same thing. We found that students were just as likely to get the next problem correct if they were proficient in the new model than if they were proficient in the old model. So that was one cool thing that the proficiency model, the learning model gave us. It also opened up new possibilities. We could determine if a student was struggling on an exercise. We could also, maybe we could use it to power an adaptive learning system. So, if we know that if we know what you already know, and say you want to learn algebra, then maybe we could give you the best combination of text, of videos, of exercises to get you from where you are now to where you want to be, to be able to learn algebra in as optimal time as possible. So we are currently working on a system that combines together videos, videos, exercises, and text. So what this does is the learning model, it reinforces mastery-based learning. So what mastery-based learning is we have students take as long as they want on a concept until they understand it, until they feel comfortable to move on. So instead of the traditional model where you might be given like 2 weeks to learn this concept and then we give you a test, we let you spend as long as you want on it. So using this system, we've built up a knowledge map where you can start off with, we have exercise on addition and subtraction, and further down you can see you can do these exercises and you can eventually find your way so that you can start doing exercise on calculus. And in fact, the really cool thing about basing things on mastery instead of based on your age is that we've seen grade 5 students work through this knowledge map and actually become proficient on calculus modules. So this knowledge map, it gives us a pretty cool, or it gives students an easy way to see what they can do next. But it's also a fairly rigid structure. They can see what to do, and it tells them whether the exercises tells them whether they got the answer correct or not. So what we want to do, what would be really cool to do is, what if we can motivate students to want to learn on their own, to want to pose their own questions, and to seek out tutorials to try to answer them on their own. The closest thing that I've come to that was a few years ago when I was in high school. I was doing some code, and I was making a little game. What I wanted to do was I just wanted to get a ball to be able to hit an angled surface, and I wanted to figure out the angle it should leave that angled surface. I didn't know trigonometry at the time, so I worked through a bunch of algebra. There was a bug in my algebra, and it didn't work. But then a day later, we started learning trigonometry. And then, it was perfect. It was exactly what I needed. So there was no persuasion necessary. I started digging into the material. I understood, why they were teaching this to us, and it was much better than just being, taught, here's the definition of sine, here's the definition of cosine. So we want to enable that experience for our users as well. And in fact, just 4 days ago, on August 14th, we launched an entirely new computer science curriculum. I'll show you one of the tutorial videos.
There are 3 steps you need to know about to make your drawings splendiferously colorful. Let's start by coloring the background. To do that, just type background and then an open parentheses, and the rest of the line will complete for you.
The cool thing here is that you can pause the tutorial at any time And then you can just start interacting with exactly what the instructor was typing in. So for example, I could just I could click on this, and there's a color picker here, and I can start playing around with the colors, and as I play around with it, the code updates in real time. And I can start typing other things, maybe like draw a rectangle or something. Let's see what that looks like, and then I can use these number sliders to position it exactly where I want. So this instant feedback loop makes it really easy for students to just experiment with numbers. Even if you don't know programming, you can just start playing around with these numbers and see what these numbers do. So if you press play, it will take away your changes, and it will resume where the instructor left off. But these computer science tutorials, we've been beta testing this with summer students a few weeks before we launched. And we've got some interesting stories. So these are middle school students. They have no experience in programming. And we just get them started with these tutorials. So here's this student who just went through the tutorials and decided to create this on his own. So here you see this this little green thing is following my mouse. When I get close to the guy, it starts flashing, and then boom. We didn't give this student any instruction. The student decided to just create it on their own. And the student had no programming experience. And this was done in an hour and a half. So at the summer camp, we heard students saying things like, I wish I could, why don't we try to draw a ball? And they draw a ball, and then they say, okay, you know what, let's try to get it to move. They don't know how to get it to move, so they start searching the tutorials that we have to try to figure out how to get it to move. And the amazing thing that's happening here is that the students are learning for themselves. Not to accrue some points, not because someone told them to, but they're learning because they genuinely want to learn how to do it. So the computer science curriculum is sort of a paradigm shift for us, because traditionally we've been telling students what to do next, and we've been telling them whether they get it correct or not. But with the computer science things, it's completely open. Students decide what they want to do, and students can decide whether it's correct or not. I just want to reflect on the current state of education. Why should there be gaps in knowledge? Why shouldn't education be a basic human right that every human being deserves? And I don't know the answers to these questions, but these questions shouldn't even exist, because we can't solve these issues. I believe education is a pillar of our modern quality of life. Now, if we can enable, if we can bring education to all the human beings, if we can bring education to all the humans, if we can give them the power, the knowledge, the curiosity, the impetus to bring their potential to light, then we can make planet Earth a better home for all of us. Thank you.